In this video, we're going to learn about Arduino sprites and how to make a better gauge. Hey everyone, this is Matt with Learn Everything About Design, and in our last Arduino video, which granted was something like 3.5 hours long, we learned a lot of the basics to build a gauge. And what we did was we took it step by step. We learned how to put graphics on the screen, we learned how to draw graphics, we learned how to put text on the screen, we learned how to get GPS data, in this case speed, and ultimately we put together an entire gauge where we had a bar sweep up and around every time we incremented the speed. So what I want to do now is I want to talk about some of the downsides to what we did and how we did it. And mainly that would be the flickering that we saw. And part of the reason for the flickering is going to be in the speed of the Arduino, the speed of the processor that we're using, whichever chipset you happen to have. And the other aspect of that is going to be memory management. Now, we're not going to get real deep into all of these topics, but the main thing that we are going to talk about in this video is going to be something called a sprite. Now, a sprite you would typically find in 8-bit and 16-bit games where you had a character and elements of a 2D game that would move independent of the background. And these sprites are going to be images that get drawn into RAM, random access memory, and then displayed all at once on our screen. So the way that we're going to talk about this is first I've got Paintbrush open again because I think this is a great tool for us to visualize the pixels themselves. And with those pixels, we're able to then better understand the graphics that we're drawing. We're also going to talk a little bit about memory in Arduinos because there's 3 different types of memory. And understanding the memory is an important topic. Again, we're not going to get real deep into memory management, but I did mention in the last video that if you're on an Arduino Uno, these are great development boards and development platforms to get started. But generally, once your projects become a bit bigger, they tend to run out of memory. And we're just going to use that term memory in general, even though I mentioned there are 3 different types of memory. But generally what happens is you run out of what's called flash memory or program memory. Now, flash memory or program memory is what we see when we are creating things like variables. So there are different variables that we store in our programs. If we use the #define, what we're doing is we're loading those into a different piece of memory than if we are creating global variables or if we're creating variables that run inside of a function. Now, the way in which we do that is going to have an effect on the overall program. And not only that, but the graphics we draw and the sprites that we use are also going to have an effect. So in this case, this was the program that we used for the GPS speedo. This was the very final one. The sketch itself uses 27% of the program storage space. And you can see it gives it here in bytes. The global variables that we used, which there were a handful of global variables for things like minimum and maximum speed, the size of the LCD, the position of the gauge, those used 4% of dynamic memory. Now, this again is on an M5 stack. It's an ESP32 board. And if you were to run this exact same program or compile it on an Arduino Uno, then you're going to notice that that program memory, that storage space, is going to be way higher than 27% if it'll even compile at all. So we're not going to go through that exercise, but if you notice as you start building programs, you start creating more variables, you start running more graphics. If you, let's say you're building sprites or you're building graphics on the screen, you'll notice real quick that you start to run out of memory. So again, we're not going to go through the process of really diving deep into memory management in Arduinos. There's lots of great information out there about that. And honestly, it's something that I have somewhat avoided by going to different development boards, getting away from something like an Uno and getting into something like the M5 stack or some of the SAMD boards like the Trinkets, the Cutie Pie, and so on. Those kind of help because they do have more available memory. So now that we've sort of talked about that a little bit, let's talk about what a sprite is and why that's important to us. So when we did our gauge originally, we simply just drew the gauge on screen. So when we drew the gauge on screen, what we did is we had a routine, and that routine started to fill out certain areas. And I'm just going to do some quick sort of scribbles inside of here. But when we started, we basically were drawing the circle for the gauge, we were drawing any lines that we needed, and then we were sort of filling in the space between with triangles. Now, that process means that what we had to do was we had to not only draw the background of the gauge every time, we then had to draw over it with the triangles. We had to plot where the triangles were going to be, and we did that every 6 degrees up until the position of the current speed. So when you're at 1 or 2 miles an hour, it's really not a big deal because you're not drawing much on the screen. But every time we went through that loop, we would have to redraw everything. And the problem with that is as you start to add more and more elements on the screen, you're going to start to notice the amount of time it takes to draw those elements, and it's going to show up as a flicker. And you can have some buffers and you can start to delay certain aspects of it, but ultimately you're going to get to a point where just visually it doesn't look good. Now when you're doing it on these small screens and you've got a limited number of pixels, it's fine. You'll also start to notice that if you display images such as a bitmap that you've converted to hex data or binary data, depending on the images you're working with, then you'll also start to notice the amount of time it takes to display those on the screen. So part of that problem is handled by using what's called a sprite. Now, a sprite is something that you typically would find in video games, but we're going to use a sprite in this case because it helps us get rid of that flicker. Now, a sprite is essentially a graphic. We're drawing the exact same thing, and keeping in mind that our examples, we're not using external images. I'm not keeping a JPEG or a bitmap on an SD card and loading that, which we certainly can do. What we're still doing is we're still drawing everything how we would draw it if we were going to just do it on the screen in live in real time. But what we're going to do is we're going to pre-draw it and then kind of just paste it on the screen. So when we use a sprite, we're drawing it in RAM. We're essentially saying that we have this amount of space and we're drawing this, and then we tell it where to put it on the screen. Now there are a couple things that we need to really know about sprites. First is we're going to have to define a sprite by a rectangular area. So we're going to have to say basically for the circle, where if we were drawing it on the screen, we could draw an actual circle. With a sprite, we're going to have to say, I need 160 by 160 pixel rectangle. And then inside of that rectangle, we're going to draw something. But the benefit of this is all of the pixels that we're not drawing on, we can instantly set to a transparent fill, which means that we'll be able to see directly through that square or that rectangle, whatever we define, except for the pixels that we determine need to be some other color. In our case, the round section of our gauge, the needle, whatever it is. And essentially what we're doing is we're building this in memory, and then we're going to just paste it onto the gauge. We're going to paste it onto the screen where we can see it. Now, when we paste it onto the screen, we need to tell exactly where that position is. So we can determine the pivot point or the set point of the sprite itself, and then we can determine where that is relative to our screen. Now remember, the positive X is going from the upper left corner to the upper right hand corner, and positive Y is starting at that same corner and it's going down, and those numbers are increasingly positive. We had to deal with that when we were talking about plotting the needle. We needed to know where that location was and work with it. So that is just at the very basics, that is how we would create and call a sprite, obviously here in Paint. But what we're going to do is actually something a little bit different. We are going to create a composite of two sprites. We have one sprite that's going to be the gauge face, so any numbers we need to display, like the speeds or the hash marks, any graphics that we want to put on the speedo, anything like that, we're going to display that in a single sprite. And then we're going to create a second sprite, which is just the needle. And what we're going to do with this one is we're going to set a pivot point roughly in the location where the needle needs to pivot. And the benefit of doing this is we can take the needle sprite and we can place it on the gauge face sprite at a certain angle. We'll feed it the angle, whether we're feeding it a speed or we're feeding it a specific angle. we can take that value and we can just simply put the needle and we can copy it onto what's going to be our gauge sprite. Now, again, one thing that we can do is we can have a transparent background. So that means that when we paste the needle on there, it's not going to overlap, or it's not going to overwrite anything behind it. So directly behind the red needle, any lines that are directly behind it will be obscured, obviously, but anything that could still be seen will still look like the needle is in front of it. And then we're going to take this entire gauge, the needle and the gauge face and all that, and going to take that sprite and display it on screen. So this method means that we're not taking the time to draw everything on screen so we can see it and we get that flicker, but instead we're drawing it in memory and then we're simply just copying and pasting it. And each time we do that, we're doing it as a composite or separate because we want to be able to rotate the needle each time. So if we were to rotate, let's say, left 90 degrees, then we don't want to have a needle drawn at each specific position. So using the sprites allows us to determine the pivot point and set the rotation of that pivot based on whatever speed or angle that we feed it into that sprite. So that is a very basic, watered down look at just the technicality behind what a sprite is. Now we need to talk about the application of a sprite. And to do that, we're going to hop into Arduino. If you're using an M5 stack, it already has a Sprite.h library included in it. And that Sprite.h library is based off of something called the TFT ESPI, and that's created by somebody called Bodmer. And that library has everything that we need to know. So in the description, what you can do is you can take a look at the link that I put to the M5 Sprite.h master on GitHub. You can also take a look at the TFT ESPI library on GitHub, which is what you would use if you were using some other display. So if you're using an Arduino board with a TFT display of any size, then you would need to manually call up and define those TFT ESPI library. And we're going to be just defining the M5 stack library, again, because it's already included. Another reason why I think the M5 stack is such a great sort of first step into this. It's a great development board. It has all of the things that you would need without having to get all those extra pieces. You don't need to get an SD card board. You don't need to get an extra display. You don't need to get a speaker or a microphone or Wi-Fi. All that stuff's already included, and it has a battery on board, which just makes it a really tidy package. So in this example, we are going to focus on creating a gauge, and we're not going to go the route of actually pulling in GPS speed because we already know how to do that from our previous video. So if you want to go that route and pull in GPS speed, you certainly can. But we're only going to be looking at the application of the sprites and how we can make a gauge in that manner. With that said, I also want to note that we are not going to go through the process of manually defining the background of the gauge. Because I've already done that, I don't want to go through the process of going through again how to draw the rectangles and the circles and the lines. If you really need information on how that works, then please go check out the previous video. We walked through everything from a very basic level. And I don't really think that we need to cover it again. So what we're going to do is I'm going to give you code, and the description of the video is the code for drawing both the needle and drawing the background gauge. And we're going to just look at applying that to understand how it works. Before we copy in any of the code that's going to draw the background and it's going to draw the needle, we do need to set some stuff up, and we need to talk about the difference between how we're actually going to draw elements into a sprite and how we can display those, because understanding that little piece of information is going to be important. We are still going to be using the same basic global variables that we used for our last setup, so we can copy some of that in, but we first are going to include a weight. We're going to define a weight, so pound define, and all caps, and we're going to set that equal to 0. So this is going to be a pause for things like scrolling or delay if we happen to need it. So right now it's set to 0, but it is a good placeholder that we can use. And remember when I was talking about memory, using things like pound define as opposed to constant int, it's going to put that information in a different part of memory. So there are volatile and non-volatile memory. We can store stuff using the pound define, or we can store stuff using ints as global variables or constants. But just keep in mind that the way that we do some of these is going to determine where those values are kept. It is important that we don't put everything in using pound define, simply because we can run out of memory and we can corrupt things, especially if you're using a board with less memory. So we're going to use it for very specific things, and then we're going to use constants as global variables. So we're going to define also our degree to radian. So remember, we use this in our code so that we could translate the degrees of rotation, and it's 0.0174532.925. Also note that the entire program, all of the code here is copied into the description of the video. So if you really want to, you can go ahead and copy and paste everything. So for example, all of the constants that we defined last time, so our min and max speed, the LCD width and LCD height, the gauge radius, the gauge width, there's a second gauge width here that I added. And this is specifically so that we could have a differing height between things like the 10, 20, 30 miles per hour, and then the individual lines below that if you want. So that's why there are two different gauge widths here, which we just used as basically the thickness of our bar the first time. And then we also have our X and Y locations, which are defined by the LCD width. And then we have a gauge delay. This one isn't really needed because we have weight defined. I'm going to leave it in there for now just because I know my board has plenty of memory and I don't have to worry about that. But just note that the weight and the gauge delay are two different ways in which we can input sort of that millisecond delay value. We can either use gauge delay, which is 50 milliseconds, or we can use weight, which right now is 0. Just two different ways to define something that you would use in a very similar fashion. Now, at this stage, this is where we need to include the M5 stack, if that's the board that you're using. So we're going to do m5stack.h. If you are using the TFT ESPI library and you're using another graphics library like the GFX library for your specific display, then you would also need to include those as well. Again, this is why the M5 stack makes this process so much easier, because it simplifies it and it already includes the Sprite.h, which is again an adaptation of the TFT ESPI that's in the description. I know that's a lot, but once you have the basics defined, sort of getting into this, then we can get started on understanding how we can use sprites. The process, I promise you, the process is relatively easy once we get some of these basics down. The next step in the process is for us to define our sprite objects. And this is an extremely important step, and it's going to be important to us because we are compositing both the needle and what I'm going to call the dial. So we're going to do a TFT underscore lowercase e underscore lowercase e capital SPRITE sprite. So this TFT eSprite, again, I mentioned that the Sprite.h library was an adaptation of the TFT eSPI sprite library. So that TFT eSprite is going to be what we're using to define the sprite objects. So this is going to be, the first one is going to be dial, and I'm going to set that equal to TFT underscore eSprite. And then inside of brackets, I need to use and or ampersand m5.lcd, and we'll close that off. And I'm going to put some comments in here. So this is going to create our sprite object for the dial. So what we just did was we essentially created something called dial, and we said that this dial is our eSprite object, and the and m5.lcd is including the LCD library from the M5 stack. So remember that when we are displaying stuff on the screen on an M5 stack, we're using m5.lcd.draw rectangle or draw fill circle or something like that, right? So that's why we need to include the m5.lcd. If you were using another TFT display, yours would likely be TFT. It would be ampersand TFT or something like that. But this is where we're creating these objects. So we need to repeat the process, TFT underscore E sprite, and this time we're going to do the needle. And again, it's going to be the same sort of thing, E sprite, and we're going to include that m5.lcd. Again, I'm going to add a comment, create sprite object, and this time it's for the needle. So with those defined, now we can get into the setup. So this is where we're going to put our code to run just once at the very beginning. And again, all of this code is in the description of the video. If you just want to download the code and try it out for yourself, then you can certainly do that. But I think it's important that we understand just the basics of how to make this work, and then we'll just copy everything in. So what we're going to be doing here is we're going to start with our m5.begin. Remember, if you're using the m5 stack, we have m5.begin and we also have power.begin, so we can use the battery. And then I'm going to start by just filling the entire screen black. A lot of times this isn't needed, but it's a good idea to just sort of wipe or start from scratch. So we're going to do black. Now, because we are using essentially the TFT library underneath the M5 stack, there are a couple different ways for us to define colors. In the last video, we did things like we just typed in black, which does work, but there's also definitions for TFT underscore black, and these work as well. Now, it's always a good idea if you're trying to expand outside of the colors that we're using for you to dive in deeper to whatever library that you are using to see what colors are already predefined. And if they're not predefined, then you can start defining your own colors based on the numeric values that represent those. Again, we're not really focusing on that. I want to really spend time on the sprites themselves and then worry later on about colors and other stuff like that. So from here, we can go in and we can draw the background and we can create the needle. Now, since I know that we're going to be doing that, I'm going to put some placeholders here, but I'm going to put them in as comments. So I'm going to create a function called draw background, and I'm going to pass it a 0. Now, the reason I'm going to do this is because I know that this function is going to be accepting an angle value, because I need to pass it that angle value in order to create the sprite needle. I need to send that angle value to the needle, or it could be a speed value. I don't really know what it is yet, but I'm just going to put a placeholder in there. And then we're going to do the same thing, create needle. Now, remember, this is still the setup. This only happens once at the very start, and then we go into our loop where things happen over and over again. Now, the main loop is where we really want to focus on understanding what happens with the sprites themselves. So I would suggest before we ever get into creating a for loop and passing it some numbers that we can sweep a gauge through, that we simply just look at how to create a sprite. Now, there are a handful of different commands that you can use. Again, I linked to the different libraries. I'm going to go ahead and pull one up on screen here. I've linked to the different libraries. This is the Sprite.h, which is for the M5 stack. And the Sprite.h, again, is an adaptation of the TFT ESPI, which is also linked in the description. But we have some options inside of here. So what we have to do is we have to first define our sprite, which we did at the very beginning. We defined the TFT eSprite as dial and our needle. And then we also need to create a sprite. And then we need to do things like set the color of the sprite, and then we can draw our objects inside of it. So with that basic understanding, let's go ahead and let's just draw some basic shapes. So the first thing that we want is we want to create an empty sort of sprite. We need to create that empty container. So the first thing that I'm going to do is I am going to decide whether this is for the dial or the needle. And notice that I forgot to put LE on there. So when we're defining these, when we were drawing objects before, we would do something like m5.lcd.draw rectangle, and then we would pass it whatever it needed. In this case, because we're not drawing directly to the display, what we're doing is we're drawing to the sprite object. So instead of m5.lcd for me, or potentially tft dot whatever for you, then what we're going to do is we're going to say dial dot, and that's going to be the call to draw something. So the first thing that I'm going to do is I am going to define the size of whatever sprite I need. So the first thing that we need to do is we need to define some parameters, things like color depth. We need to define the size of the sprite, the pivot point, if there is a pivot point, and so on. So we're going to do set color depth, and we're going to set it at 8. And now there you can set it at 8 bits or 16 bits, but we're going to set ours at 8. And the next thing that we're going to do is use dial dot create sprite. And then we're going to define the size of the sprite. Now for the gauge itself, because I'm drawing the entire screen, I'm going to set this at the entire gauge width and height. So LCD width, because those are global variables, by LCD height. All right, so now that we've created our dial sprite that's the size of the entire LCD, let's think a little bit about the loop and what's going on. We're setting the color, we've created the sprite, now we need to populate the sprite with something. For this first example, what I'm going to do is say dial dot, and then we're going to create a filled circle. Now, we have to think about a couple of things first though. Before I create that filled circle, I think it's good practice for us to fill the sprite with a color. Now, if you want it to be transparent, there is a TFT underscore transparent that's already built into the eSprite library, which is, again, part of Sprite.h, which is built into the M5 stack. So if you're using the TFT eSprite library, or if you're, ESPI, which is part of the eSprite, then you can just go ahead and do TFT underscore transparent. So that's the first thing that we're going to do. And keep in mind that we have a couple of things. We have fill screen, and we also have fill, we can have a fill for the sprite. So at the very top in our setup, we did m5.lcd fill screen, which instantly pushes that color to the screen. What we're doing now is we're filling out the image that we're creating in RAM. So nothing is getting displayed on the screen yet. So the first thing that we should do is we should fill the sprite, and I'm going to say TFT underscore transparent. Now this is good because this means that any pixel that we don't fill with a color is going to remain transparent or see-through. The fact that that's already predefined for us makes it so much easier. The next thing that we want to do is we want to build out whatever shape we want. So in this case, I'm going to say dial.fill_circle. And because we are using the constants that we created, our x location and our y location that are predefined as global variables, we can use here. So x LOC is for x location, and then y LOC is for our y location. Now remember, with a fill circle, we need a radius value and then a color. So what we're going to do is we're going to say that the radius value is our gauge rad, and then we're going to give it a color. In this case, I'm just going to say red. Next, we're going to create another filled circle, but this time what we're going to do is we're going to make the center of this one transparent. So we need to use x LOC and y LOC for the location. We're going to do gauge rad minus, I'm going to do gauge width 2 because it's a very small number. We could also manually enter a number here, gauge width 2, and then the color is going to be TFT underscore transparent. Now, theoretically, what we've done so far is we've created this sprite that's the size of our LCD. Again, it's in RAM, it's not being displayed. Then what we've done is we've gone ahead and we filled it with transparency. We've said that we wanted to make a red filled circle, and then we created a smaller transparent circle in the center of it. So theoretically, the center of this sprite, when it's displayed on the screen, should automatically see through to whatever is below it. But that brings me to the second point. Because this is a loop that we're going to constantly be going through, I'm going to go ahead at the very beginning and say m5.lcd.fill screen, and I'm going to do TFT underscore blue. Now, when I'm doing like red or TFT red, the main difference is just it's calling it from a different library. Now, the colors themselves, again, are defined by actual values there are numerical values that are used in the back end, and red and blue and all these different colors are already predefined for us. So an example of that, the TFT blue is going to be 0x001F, which means that it's 0 for R, 0 for G, and 255 for B, or blue. So those are the representations when we're using the color definitions in the back end. It just so happens to be that these values are already predefined. And with that, I should also note that we are predefining LCD width and LCD height. We don't really need to do that. Most displays will have a TFT width and a TFT height value that's already pre-programmed. You can change the rotation of them to determine how things are going to be displayed on the screen. The main reason that I put that in there is because it gives us the ability to reduce the size that we're displaying this. So for example, if we wanted to display 2 gauges at the same time, instead of redefining the entire program, we could just change LCD width and LCD height, and that would make the little box where the gauge is being displayed smaller. Now, in reality, what we should do is make things like the gauge radius to be some sort of value that is dependent upon the width or the height or both of them somehow. Now, it's all just hard-coded in there for those global variables, but again, I should note that in the back end, there are actually a couple of extra things where we can call upon and get the width or the height of the LCD in almost all cases. There is also something that we should consider. In some displays, we'll be able to build the pixels outside of the actual display area. It'll sort of store that information in a buffer, which allows you to predefine and scroll things from one side to the other a little bit easier, because you can build some of those pixels outside and just shift or translate them. Again, outside of what we're doing here, but just a couple extra notes of things that you can do, steps that we took that may or may not be needed, like defining the width and the height of our LCD. Okay, so now if we take a look at our loop, we're filling the screen with blue, which again is the RGB value 00255. Then what we're doing is we're setting the color depth. Again, this is something that we're determining the number of colors that we're using to be represented on the screen. We are creating our sprite based on the LCD width and height. We are filling the sprite with TFT transparent. Again, remember that we can do things like fill screen, also fill sprite. So that's an important distinction that we should think about. We also created a red circle, and then we created a transparent circle just slightly smaller than it. Now what we need to do is we need to push the sprite to the screen. So what I'm going to do is say dial.push sprite. Now when we push a sprite, we need to give it a coordinate and we need to tell it the color. Now in some cases, depending on the library you're using, the color will be optional. But for us, this sprite is actually defined as the entire LCD size. So we're going to stick it at 0, 0, the top left corner, and I'm going to make it TFT transparent. So essentially what we said is we filled the background with blue, we made a sprite, we set it as transparent, we built a red circle, we removed the center, and then we pushed the sprite to the screen. Another way that we can think about this is that we have created this sprite digitally in the memory, and then we've just copied it and pasted it to our screen. So again, how we looked at it in Paintbrush, it's kind of how we did it here. The last bit of this is we want to release the sprite from memory. We're going to use dial.delete sprite. And the reason that this is important is because the sprite is going to take up memory, and each time we go through this infinite loop, it's going to continue to fill that up until eventually it's corrupted and the program will fail to run. You'll also notice in some of the sample programs, you might find a yield command. So you may see yield in there. So depending on the chipset that you're using, again, the M5 stack is an ESP32. There are some other ESP variations that have what's called a watchdog timer. And what the watchdog timer is doing is it's essentially looking in this infinite loop to see if anything is taking longer than, I don't know, a second. I'm not sure exactly what the time is, but let's just say a second. And what yield does is it allows things to be running in the background and prevent that timer from basically resetting the program. So we don't necessarily need it. In our case, it could be helpful depending on what processor you're using. But just note that if you're looking through sample code for the TFT ESPI library or the M5 stack sprite library examples, then you might see that yield command. And again, it's there in case something in the background is taking longer than a second. That would be pretty heavy for something to be taking that long for what we're doing at least. So I don't think it's going to come into play. Okay. So we've created our dial sprite. Now that's this one right here. We still have another sprite that we initialized the object at the very beginning called the needle sprite. So what I want to do is I want to create another needle or another sprite, and we're going to basically do the same thing, but we're going to create a triangle or an object. So for this one, I'm going to say needle dot create sprite. And we need to give it a length and a width. And in this case, I'm going to say it's 10 pixels wide and 100 pixels tall. And what that allows us to do is basically we're creating a 10 by 100 box that we're building inside of. Now that we've created that, I'm going to fill it. So again, needle dot fill sprite. And we're going to use that TFT transparent again. And then from here, we're going to create whatever object is inside of it. So I'm going to create a filled circle. So I'm going to say needle.fill circle. And I'm going to put this halfway between. So I'm going to put it 5 pixels in and 5 pixels down. The radius value, I'm going to make 2. And then what we're going to do is we're going to give it a color. And remember the circle that we created, or the outside we created, was red. And we can go ahead and make this whatever color we want, but I'm going to just go ahead and make this black. And again, black or TFT black theoretically will give you the same. If you go through the library, you'll find that there are a lot of colors predefined. And why don't I go ahead and I'll just bring that up on the screen so we can see it. Let me go ahead and just find it real quick. All right, so here we can see that this is inside of the M5 stack library on GitHub. The display right here in defines.h. These are the width and the height of the LCD, and you can see these are the predefined colors that we can use. So notice that down at the bottom, we've got, in this case, we've got ILI 9341 black, and then we've got just black. They're both defined the same, and you can sort of interchange both of those. Also notice that there are TFT values, and if we go down, there are some more TFT values and ILI values. And it really just depends on which library is being used. So if you're using the TFT ESPI library, or if you're using the M5 stack library, or wherever you're pulling this data from, just note that there are predefined colors, so we don't have to manually create those. A lot of those are already pre-created for us. I'm just sticking with very basic colors, black, blue, red, and so on. But obviously you can dig through those libraries and you can figure that out, whatever library you end up using. Okay, so now we've created a very small fill circle. It's 5 pixels in, 5 pixels down. And what we're going to do is we're going to define just a line or a triangle or something. So we do needle dot, and depending on what you want, again, just pick whatever shape you want to create. It doesn't have to be exactly what I'm doing. Just create a shape. For me, I'm going to use the fill triangle. And this is the same thing we did when we were creating our last gauge where we swept that shape around. So this filled triangle is going to require us to give it 3 individual points as well as a color. So my first point, we need to think about the fact that the center of our circle is at 5, 5. And it has a radius of 2, which means it's 4 pixels wide. So my width of that sprite is 10, which means that the circle is taking up 4 out of those 10. And if I think about that, 4 out of the 10, we have 6 pixels left. So my first triangle point is going to go in 3 pixels from the side and down 5. The next one is going to go into the other side of our circle, which should be 6, down 5, and then we're going to go over 5 pixels directly in the center, and we'll go down 100. And make sure I put a comma in there. And then we're going to give it a color, and I'm just going to say black again. So it's going to be the same as the other piece that we created. And I'm going to do this one more time. Needle, fill, circle, and I'm going to put it at 5, 5. This time I'm going to give it a radius of 1, which is really small. And I'm just going to put a white dot in the center. Now that we've created this needle, we need to also position it. So we're going to push it to the TFT, and we're going to position it relative to what we have on the screen. So needle dot push sprite. Keeping in mind, we're not even talking about rotation or anything like that yet, because there are set pivots and all kinds of things. So my plan here is we're going to do this example, and then we'll copy the code that we already have, and we'll look through it so make sure we understand it. So we have needle push sprite. Remember that our sprite, if we put it at 0, 0, will just come in the top left corner. We want to move it over so it's centered on the gauge, but we haven't told it where the pivot point is. So we have to tell it where the top left corner is going to be. The top left corner is going to be 5 pixels to the left of center of our gauge. So if we use our X location, we can do X LOC minus 5. And then our Y location will be Y LOC. But this time, keeping in mind that the pivot point or the center of that little circle is 5 pixels down on our example. So what we actually need to do is we need to think about this in terms of that Y location being 120 pixels down, but then we need to shift to be smaller. So again, we're going to subtract 5. So that puts our left corner exactly where we need it. Now we need to tell it what color it is. And again, TFT, transparent. Unless you happen to need a very specific color for the entire sprite, most of the time you're going to be using TFT transparent because it's one of the main benefits of our sprites here. And then we're going to do a needle.delete sprite. We want to make sure that we clear the memory. There's a couple other things I want to do in here. I'm going to add a delay, and I'm going to put a 1-second delay at the very top. And I'm going to put another delay here of, let's say, 2 seconds. So that way we just can see it happening on the screen. Let's do a quick save, and let's go ahead and push this to display and see what this looks like. So obviously that didn't work because there are some typos. Now this happens to me all the time. I put a colon instead of a semicolon. We'll just do a quick save and we'll try to upload it again. So you can see everything seems to work. We've created the red circle and then we've created the black needle which displays in the center of the gauge. It does slightly overlap the red circle, which is exactly what we want. There is a little bit of a flicker there that happens, partially because we've added those delays, but essentially what we have is we've got the basis for a gauge. So at this point, if you want to keep this code, then go ahead and make sure you save it as something else. Again, what we're going to do is we're going to essentially wipe everything that we have here, and we're going to add in some additional information. So what we want to do now is we want to bring in a couple other pieces of information. And what you can do is you can go down and copy the code that's in the description of the video and put it into this Arduino sketch or a new one. So that way we can review what's happening and then we can take a look at it to see what that looks like on our M5 stack. So for me, I'm going to get rid of everything from void loop down. I'm going to go ahead and paste in my code and then we'll take a look. So the first thing that happens, you'll notice that everything before the loop stayed the same. Inside of my setup, I can get rid of the comments for draw background and create needle. So essentially what's happening inside of our loop right now is we've got a for loop. What we're doing is we're creating a variable that goes from 0 to 270 in 5-degree increments. And we're also sending some variables into plot gauge. We're adding a delay and we've got yield. Now, theoretically, you'll notice that I've got the needle delete sprite commented out. Again, it is important that we do think about deleting these sprites. There will eventually be a memory overrun. At least I believe that. I've never hit it, but I believe that that's what will happen. So it is important to consider when we're deleting those sprites and the fact that we don't necessarily need to keep them in memory. We're just going to keep redrawing them. So what we're doing inside of our setup is we're drawing the background and we are creating the needle. So these are two functions that we're calling. We're passing 0 to draw background, and we're not passing any arguments to create needle. Inside of our loop, we're going from, again, 0 degrees up to 270 or just below 270 in 5-degree increments. And then what we're doing is we're plotting the gauge. Now, plotting the gauge passes two things. It passes ROT for rotation, and it passes a string called MPH. There's a small delay that happens in here, and then again, that yield. Remember, yield is something that's important on some of the ESP chipsets. It doesn't really apply universally. And then again, I've got this needle delete sprite commented out. Keeping in mind that we do have two sprites, we also have the dial. So theoretically, we should also have dial.delete sprite in here. And again, these are things that you should just be mindful of. You may or may not necessarily need them, but again, I think it's good practice to make sure that we clear the memory that the sprites are taking up. The next thing that we do is we've got a couple of our custom functions. So we've got plot gauge, which is what's getting called from the loop. And this is looking for two arguments. It's looking for an angle, and it's also looking for a label. Notice that I've got something commented out inside of here called m5.lcd set pivot. Now, this is important. We're going to talk about this in just a second, but just note that that's commented out right now. So inside of here, what we're doing is we're calling draw background, and we're passing it an angle. Remember, in our setup, we passed it a 0. And then we're calling needle.pushRotated, and then we've got an ampersand dial, angle, and TFT transparent. Now, this is important because push rotated is only expecting two arguments. So what does this really mean? Well, the way that we're doing this is we're pushing the needle, or rather the rotated version of the needle, to the dial sprite. And then we're taking the entire dial sprite and we're pushing it at 0, 0 because it takes up the entire screen. So if we take a look a little bit deeper into these, draw background is looking very similar to what we've already done so far. We are setting the color depth, we're creating the sprite, but this time what we're doing is we're setting the pivot point. Now here is where this is important. Inside of draw background, we are setting the pivot point on the sprite, because we're using dial.setPivot, at the center. Remember, LCD width divided by 2, LCD height divided by 2, which is also going to be the value of our X location and Y location. We could use either of those, or we can manually code it in. Then what we're doing is we're saying the pivot point on the LCD itself, so this one here is the pivot point on the sprite, the pivot point on the LCD is going to be that same location. Now this is actually a critical step to make sure that the needle goes in the right place. If we only set one of these, then I don't think it'll work. I think you need to have the pivot point set on both the sprite that we're passing the needle to, as well as the display itself. Then you can see that we're filling screen. We also have the ability to fill sprite. I think both of those will work the same essentially, but just note that I opted to use fill screen here instead of fill sprite. Then this is essentially just drawing the entire background. So if you look at what we see on the screen here, what we're doing is we're drawing the background of the gauge. We're drawing a round rectangle, which is 3 different round rectangles for the border set in white. We are drawing a fill circle in white, and we're drawing a fill circle in red. And then what we're doing is we're drawing some additional round rectangles and fill circles in red, white, and black. And what this is doing is it's building out the speedo section with the little bump out for the text where the speedo number goes. Then we've got some for loops that happen down here. Now the reason for the for loops is because we're creating blue and black lines for the segments that happen as the needle sweeps and goes around. So this is sort of a one-time thing that happens when drawing the background. We're using some of the same values that we used in our previous gauge, where we were looking at finding the coordinates and the angles, and we're wrapping these lines around. Every 20 degrees, we are creating this line here, which is the gauge radius minus gauge width. This is the thicker value. And then every 2 degrees, we're creating the smaller line because we're using gauge width 2, so that's 10 subtracted from the gauge radius. So we're creating smaller lines every 2 degrees and the taller lines every 20 degrees. Then from here, what we're doing is we're mapping, again, we're mapping a speed value based on 0 to 270 as our input, and we're mapping it from 0 to 120 miles an hour. Now, we could have used values such as the min speed and max speed, but in this case, because this was just a display sample, I just ended up hard coding those numbers in there. Then we're using some other functions that we haven't seen before, draw number and draw string, essentially like setting the cursor and pushing a numerical value, or setting the cursor and pushing a string value. So we're pushing the mapped speed u value, and we're also pushing text for miles per hour. Now, remember that we do have some values, the string label that we could pass. So instead of miles per hour here, I could just pass the variable label and it works exactly the same. I just put the string in there in quotes so we could see that. So you could manually code it in, or you could pass it into this as an argument. Now, if you're thinking about this in the bigger picture, the reason that you would want to pass in a variable rather than hard code it is if you had a configuration like miles per hour versus kilometers per hour, and you wanted to be able to configure the global, the variables, not necessarily global variables, but the variables that are based on that. So the string kph versus mph, and the conversion value of the speed, which in this case comes back to map. So when we come back to this map function, or we're mapping the speed, then the values 0 to 120 would be changed based on kilometers per hour or miles per hour, or so on. So again, that's a reason why you would want to pass variables rather than hard coding the strings in there. As we go down through here, that is going to be the entire function that draws the background. That's the entire gauge background, everything but the needle, and actually the values such as the speed that we're passing. So it maps the speed value, and it draws the speed, which in this case, that is just a fake value we're passing it. So it takes care of all that stuff in the background. Then we've got one more function here called create needle. Now, create needle is, again, setting the color depth, creating a sprite that's 20 by 100, filling the sprite with TFT transparent. Again, up here I chose to do fill screen, down here I chose to do fill sprite. Part of the reason is because in the gauge background, it's taking up the entire screen. In this one, it's a much smaller thing, and I wanted to make sure that we filled the sprite with transparent because this will be displayed over another one. And as we go through here, it's fairly simple. There's a filled circle and a filled rectangle, and then a triangle and a circle. So again, I didn't really want to sit here and I didn't want to walk through the process of coding and figuring all this stuff out. So it's here if you want to play around with it, change some of the values, change some of the numbers, and get an idea. You obviously can make up whatever shape you want. You can take a bitmap image and convert it so that you can just call that function and display it on the screen. But I thought at this stage it was important that we understand that even though we're using sprites in the background, which typically would come from images, we can still hard code those and just build them in the background and display them all at once rather than having to draw them on the screen. The last thing that happens in this create needle is the set pivot line. And the set pivot line is basically saying that the pivot point is 10 pixels in and 10 pixels down. So that's half of the width of the sprite. And again, there are functions where you can get the width of the sprite and you can use that. I just hard coded it in. But again, if you are thinking about this long term and you want to build a gauge that can be scaled up and scaled down by the user with button inputs, then you want to be really mindful of where these numbers come from and how you manipulate them. So if you're passing a variable for the width of the sprite, for example, then you would want this to be that variable divided by 2. Or again, you can actually call it in the software. You can say needle.get sprite width, or I don't remember exactly what it is, but there is a call for sprite width and sprite height. So we're setting the pivot at 1010 of this sprite. So now that we see how the background and the needle is drawn, inside of plot gauge, we have a function that is taking the angle, which theoretically, if we were hooking this up to GPS, that angle, instead of coming from a for loop, would be directly coming from GPS speed. And then it's passing that label, that string label, which again, the reason that you would want to do that is if you're allowing the option to convert it on the fly. So if you're going from miles per hour to kilometers and so on. So again, we didn't need this pivot point here, but I left it in here as a talking point to make sure that we understood that the pivot point is important. So inside of plot gauge, we're drawing the background, which happens first. So we build out the entire background of the gauge. Remember that that is happening in memory. So we're doing that in memory because we're doing it as a sprite. Then we are coming through and we are going to needle push rotated, which is sending the angle, which again theoretically would be the speed, but we're sending the angle and we're creating a transparent, in this case, a transparent needle on the dial sprite. That's the critical bit of this, is that the ampersand dial is pushing the needle, push rotated, onto the dial sprite, and then we're taking the dial sprite and we're pushing it to the screen. With all that said, let's go ahead and save this and let's upload it, and let's make sure that it all works and that there aren't any text errors in there. All right, so we can instantly see that there is a problem here. Inside of draw background, I never passed it that label. So the label is getting passed into plot gauge, but draw background is only looking for an angle. If we want to pass it the label, what we would have to do is we would have to say string, and we would say that we're passing it the label in. And then when we call to draw background, we need to make sure that we do pass that label along with it. Now this means that anywhere that we call draw background, so for example up here, we need to pass it a label. So if we want to pass KPH the first time through, we can, but we do need to make sure anytime draw background is called that we are giving it all the arguments it's expecting. So I'm going to save this and let's try to upload it one more time. So we can see that everything appears to work. The small lines are hard to pick up on the video, but they are there. It certainly looks a lot better in person than it does across the video. But note that we never put a for loop to bring the needle back down. It's only going up to 270, and that's what's happening inside of our loop. And what it's doing is it's just kind of going through and it's picking up those that angle each time and it's repopulating it. Now, as you look at it, you might think that the needle looks like it's flickering a little bit. It's actually not flickering, but part of the problem is what we have is a triangle overlaid with a rectangle, and we're on a pixelated screen. Like we have decent resolution with this small screen, but it is still a small screen looking at pixels. So what that means is that as it rotates around, there'll be areas where the pixels look better. So for example, when one of the edges of the triangle actually becomes horizontal, then it's going to look a little bit cleaner. So as it sweeps through across that white gauge, it just looks a little bit different. But we've built everything out. We did it all with code. And again, I did pass the code to you, but we did it all with code. And the main things that we really want to make sure we understand are the fact that we are pushing one sprite, a needle sprite, that we're passing an angle to using push rotated. We're passing that needle sprite into our dial sprite. We're compositing those together, and then we're passing that entire thing using dial push sprite at 0, 0. This is a much smoother result than what we had when we were drawing everything on the screen. Now, either option will work just fine. You will just get more flickering with the other option where we're drawing everything in real time. Whereas when we draw it with a sprite, what we're doing is we're building this in the back end and we're just displaying it on the screen as needed. So, again, that's the basic process. If you have any questions, then please let me know. This was an interesting thing for me to try to figure out. I've always kind of been interested in working with sprites, but more so in trying to do it in 2D games. But this was something I came across in the TFT ESPI library about compositing the two different ones together. So I thought it would make a good sort of extension to the first video, give you a little bit better option for a higher resolution display without any flickering, without having to do that buffer. The next step from here is if you like this display and you did follow along with the first one, then maybe try to take the GPS information and port and pass it over to this example. See if you can get it from passing a rotation value from 0 to 270 and actually pass it the GPS value and get that to display on the screen. But that's going to be it for this for right now. I do have a long-term goal with this. Now, my intention with doing all of this is to rebuild a dash in a 1980s car that I have. And I'd like to keep the dash looking as stock as possible. So I'm going to be using images and graphics to create a background. And I'm going to be using that as a sprite, pushing that, and then animating the needles in front of it. So that's ultimately the goal on a much bigger display. This is a great starting point to understand the concepts of working with sprites and sort of overlaying or compositing them together. So as I said, if you have any questions, please let me know. As always, thanks for watching, and we'll see you in the next one.